variations of the conditional statement. So we have 4 here, which is the first one, conditional, then converse, inverse, contrapositive. That's on the second column. You can see the symbolic form equivalent, and on the third column, the English translation. So let's start with conditional. Conditional and uh, contrapositive are equivalent. So again, conditional and contrapositive are equivalent. So we need to prove this, whether they are really equivalent. So what do you mean by equivalent statement? Equivalent statements are made up of the same simple statements and have the same corresponding truth tables or values for all true-false combination of these simple statements. So that's the definition for equivalent compound statements. And try to pair converse and inverse are also equivalent. So we will see that in few minutes if they are really equivalent by showing the truth table. So that's the converse and the inverse. Okay, so remember the symbol for conditional is an arrow going to the right, just one directional arrow, and that would mean if you're using P and Q, if P then Q. So that's how you read that. Okay, and the wavy symbol is the word not. So that's not P. Okay, so let's look at also the examples. Okay, give you a chance to look at the examples for conditional, converse, inverse, and contrapositive. Okay, so let's switch screen so we can show you an example. So what we're trying to do here for our example is trying to prove if conditional statement like P conditional to Q, it's equivalent to not Q conditional to not P. Again, you can read that as if not Q, then not P. So that's the same. So the symbol for equivalent is this one. So this means equivalent. Okay. So what we're trying to do is showing you if they're really equivalent. So we have to look at the outputs for the statement on the left and the output also for the statement on the right. So if they are exactly the same with the truth table and the true false output, then they are really an equivalent statement. So let's create the truth table. So looking at this, you have P and Q. It means you have the formula 2 power of n. So it means 2 power of 2, you'll get 4 possible combinations. So let's make that P, Q, and then we need to have 4. 2, 3, 4. Okay. And then our statement is P conditional to Q, or if P then Q. So let's start on the second column. Creating the truth table, you start with T and then followed by F. Just alternate T, F. And on the first column, 2 T's and then 2 F's. Now, remembering our uh, conditional truth table from the previous section, we have true to F, or true for antecedent and false for consequent. Then you will get false statement. So that should be false on the second row. T going to F, that should be F. And then the rest would be T. Okay, so that's the outputs for that statement. So let's continue our analysis. Now on the right side, you have this not Q and not P. So we have to put that in. Let's extend our truth table. So we have to create not Q and then not P. Now looking at not Q, you're looking at the second column. So just take the opposite value for the second column. So you have T, we'll get F here, then T, because that's F, and then you have a T, that should be F, and the last one would be T from F. And then for not P, you're looking at the first column and take the opposite of the values there. So true, you get false here, and then false, and then true, and true. Okay, and let's write the statement that is not Q conditional to not P. Or if not Q, then not P. Now, let's remember again our truth table for conditional. So that's 2. Uh, you're looking at second row, TF. You should get F. And the rest would be T. And now you can compare the outcome. So you're looking at comparing this. This is the contrapositive. And then you're looking at the conditional on this side, which is this third row, column, I mean. Okay, so you can see the values would be in the third column, that's TFTT, and on the last column would be TFTT. So they're exactly the same. So therefore, they are equivalent. So So that's how we know. Okay. Next example, we have Q conditional to P, and they are equivalent to not P conditional not Q, or if not P, then not Q. Okay, so we're trying to create the truth table again, and you have two symbolic letters, so that should be four possible combinations. Again, four possible combinations from the formula 2 raised to the power of n. So you have four, and create the truth table by the alternating values here. The second column, and the first column, first two t's, and then two f's. And then let's write the statement here. Remembering again the conditional truth table. So you have TF, that's the second row. You will get F here, and the rest would be T. Okay. Next, we're looking at not P and not Q on the right side of the uh, compound statements. So we will extend this, and then we will have that not P and then not Q. Okay, so not P, you're looking at the second column and take the opposite. So F, T, F, T. For not Q, you're looking at the first column and take the opposite values. Okay, and let's write the statement. Okay, so conditional, that's T going to F, second column, you'll get F here, the rest will be T. So we can compare the results now. So this is the result. Uh, this is the converse. And the last row, that was the third column. And the last column would be the inverse. Again, converse and inverse are equivalent in this case because look at the outputs. You have TF, TT on the third column, and the last column is the same value. So therefore, the two are equivalent. Okay. So that's how we know they are equivalent. Okay. And let's go for the next example. And this is our final example. We're looking at not P, conditional to Q, and try to prove Q conditional to not P. Q conditional to not P. Okay. So we do not know if this one is equivalent or not unless we will actually do the truth table. So let's do the truth table again. You have two symbolic statements and symbolic letters. I mean, so that would be 2 power of 2, that should be 4. So you have now 4 possible combinations. So again, okay. And let's put the values. T here, F alternates. And then in the first column, that would be 2 T's and then 2 F's. And then we're looking at not P. So let's put that not P here. And let's try to extend our truth table. So not P, you're looking at the first column and take the opposite. Values. And then we're looking at the second column. The second column, which is Q. So we can write the statement now, not P conditional to Q. Okay. And then we can evaluate now. So what we're looking at in this fourth column, that would be the outcome, the outputs. So you're looking at the third column and the second column. Okay, again, you're looking at the third and the second. So the outputs would be, you're looking at TF, okay, from the third column to the second column. So TF is right here. You're looking at TF. So this is the only combination you have. So that's TF. And that should be F for the outcome. And the rest would be T. Okay. So next, we're looking at the other statement. So the other statement, it says Q conditional not P. Or you can see if Q then not P. Okay. So what would be the column that we are looking at? Q. So Q, that should be here, second column, and not P, that would be the third column. So let's start looking at the TF. So the TF is here. So the TF would go F here, and the rest would be T. Let's see if there's another TF. There's another TF, so that should be T for the rest of them. And then now you can compare. So this is the outcome here for the last column, and compare it with the fourth column. Again, fourth and the fifth column, you compare and look at the values. So it's not the same. So therefore, they are not equivalent. Now the three dots here means therefore. The word therefore, that's the symbol. Therefore, equivalent. So this is how we show if the two statements are equivalent or not. Okay, again, the foundation here is knowing our truth tables. So memorize the truth tables. So we can actually uh, decide and compare the two statements whether they are equivalent or not.